Today's topic is flow control, stop and wait control and sliding window protocol. Flow control. What is the need of this flow control? While sending the data from the sender to the receiver, the flow of data needs to be controlled. Suppose just imagine that there is a sender and a receiver, and the sender is sending the data at a rate higher than the receiver is able to receive and process it. Then the data will get lost. The flow control methods will help in ensuring that the data doesn't get lost. The flow control method will keep a check that the senders send the data only at a rate check, that is, there will be senders with, that is, the flow control mechanisms will keep a check that the senders send the data only at a rate that the receiver is able to receive and process. There are mainly two ways in which this can be achieved, that is, using stop and wait protocol and sliding window protocol. And what is the stop and wait protocol? It is the simplest flow control method. In this, the sender will send one frame at a time to the receiver. The sender will stop and wait for the acknowledgement from the receiver. You can see here there is a timeout mechanism. The first figure a frame is, we are sending a frame from sender side towards the receiver side. Receiver, after receiving the frame, is giving an acknowledgement. Acknowledgement is coming within the time of timeout. So that frame, the sender makes it clear that receiver had received that particular frame, and acknowledgement is had been received at the receiver side. The second scenario is figure B. A frame has been sent from the sender towards the receiver, but the frame is getting lost in the middle. After timeout mechanism, the sender will be waiting up to the timeout period. Then the sender will be sending the frame once again, and the receiver will be sending the acknowledgement. That is figure B. Then figure C is sender is sending a frame and receiver is giving an acknowledgement, but the acknowledgement is getting lost in between. So the frame is after the timeout. So the acknowledgement has not been received at the sender. Acknowledgement has not been received at the sender side. So the sender will be sending the frame again, and the acknowledgement from the receiver will be given to the sender. So at the receiver side, you can see here that a duplicate frame, the same frame, since this acknowledgement is not receiving at the sender side, the same frame is getting sent once again. Then there is the case of the last case, that is D, figure D. Frame has been sent, then there is a timeout kept. Within that time, the acknowledgement has not been received at the receiver side, so acknowledgement is receiving after the timeout. Since the timeout has happened, sender will be sending that frame once again. So at the receiver side, due to the frequent timeouts, sender will be sending the same frame twice. So in order to avoid that, we will be using a sequence number, frame 0. After that, receiver side, it will be sending the acknowledgement 0. Then this is 1-bit sequence number. In the case of 1-bit sequence number, after receiving the acknowledgement 0, if the timeout happens, but just imagine that acknowledgement 0 has the acknowledgement 0 received at the sender side after the timeout. It was frame after sending the frame 1, acknowledgement 1 was sent from the receiver side, Then frame 0, it will be sending a frame 0. If the timeout has happened, then the frame 0 will be sending again from the sender side. Then acknowledgement 0 will be sending back. If it is getting 2 frames of the same sequence number, it is easy to identify by the frames by using the sequence number. Stop and wait protocol. Just see the sender side and the receiver side. Sender is having certain frames to send to the receiver. See, sender is sending 1 frame to the receiver. Receiver will be checking this frame and seeing that is there any error in the packet received. If there is no error, then it will be accepting the frame and it will be sending an acknowledgement. Suppose if there is an error in the frame, after checking it, you can check it by using checksum and all. If there is no error, then it will be accepting, else, and it will be sending an acknowledgement back. There is no error, it will be sending an acknowledgement, and that indicates that the frame, that particular frame has been sent by the sender. That sender sent frame had been received at the receiver side and acknowledgement also received. Now we can send the next data frame. Now check this case. Here we can see that sender and the receiver, the case which I had explained right now, that is, there is a timeout mechanism. Sender will be sending a frame to the receiver. Receiver, after receiving it, will be sending the acknowledgement. If it is coming within the timeout limit, then it will be accepting that acknowledgement. Else, suppose in another scenario, a frame has been sent, but the acknowledgement is getting lost in the middle. So it will be waiting, the sender will be waiting up to the timeout time. If it has not received the acknowledgement, the sender will be sending the same frame once again, and acknowledgement will be received at the acknowledgement sent from the receiver side will be reaching at the sender. Got it? Packet received twice. So here frame has been sent, but the frame is getting lost in the middle. So after the timeout period, the sender will be sending the frame once again, and the receiver will be giving out the acknowledgement. In the next scenario, frame has been sent. Acknowledgement had been sent, but timeout happened. Timeout is frequent, so the same frame need to be sent once again. So the same frame has reached at the receiver side twice. Next we can go towards sliding window protocol. Sliding window protocol, in the stop and wait protocol we had seen that only single frame can be sent at a time, whereas in the case of sliding window protocol we can send multiple frames at a time. Number of frames to be sent is based on the window size. There is a size of the window. Each frame is numbered, or there is a sequence number. The sliding window protocol, there is a sender and the receiver. There is a window size 4. See, 10 frames are there waiting to be delivered from sender to the receiver. Now see what happens. First the frame 0 is the sender is sending the frame 0 and the receiver is receiving it. There is a window size, that means that 4 frames it can send at a time. Multiple frames can be sent. Then it needs to that sender receiver can send a receiver after getting 4 frames. See what happens. There is a window, that is a sliding window, that is blue color, which has been shown here. This sliding window has here it is kept just above this first frame. After sending the first frame, the sliding window is here. Then sending the second frame. Up to 4 frames we can send at a time. Second frame, after sending 2 frames, the sliding window, you can see here, it has just moved here, and then we can also it had from the sender to receiver 2 frames have been sent. Then in the next case scenario, that is 3 frames had been sent. So the sliding window slided towards 0th frame, first frame, and covering all these 3 frames. Then 4th frame is getting sent. So 0, 1, 2, 3, 4. Sliding window is covering all the 4 frames and window size is 4. So after 4 frames, what we are supposed to get? An acknowledgement, right? So acknowledgement can be sent from receiver can send the acknowledgement after receiving 4 frames. So it can send the acknowledgement. It can it can just store these frames and send the acknowledgement. See, next one acknowledgement had been sent. See, before sending acknowledgement, all the frames that had been sent were covered in the sliding window. Now, after sending one acknowledgement, the sliding window is going to move. One acknowledgement, 0 is going to get acknowledged. So the sliding window is about to move from 0, 1, 2, 3 to, it will be sliding towards the side. Got it? 0, 1, 2, 3 to the side. See, it is getting slided. So 0 acknowledgement. Once it had received the acknowledgement, the sliding window is getting moved towards the towards the side. See, got it? Then in the next case, first 0th frame and first frame, the acknowledgement had been sent from the receiver towards the sender. Then the sliding window is getting moved. That is 2, 3, 4, 5. These are the frames. Now it is sending the next frame also. 2, 3, 4, 5 frame had been sent, and these are the frames which had been sent, and it is waiting for the acknowledgement. Next again 3 frames got the acknowledgement, 0, 1, 2. Then the sliding window again move towards the other side. It will be sending 3, 4, 5, 6 frames had been sent, and these are waiting for acknowledgement. Up to 0, 1, 2, they had receiver had sent the acknowledgement. 7, 8, 9, 10 waiting to be delivered. This is sliding window protocol. That is, the window is getting slided. There is the receiver and sender maintains a window size. So from this figure, it is clear that 0, 1, 2 that already sent and acknowledged frames are those. Then the blue marked sliding window, that is already sent but not acknowledged yet. 7, 8, 9, 10 not yet sent from the sender side. There is a timeline. Sender and receiver will be sending the frames and receiver will be giving out the acknowledgements. There is a in this sliding window protocol, sender assigns a sequence number denoted as sequence SEQ num to each frame. There is a sending window size, last acknowledgement received LAR, and last frame sent to be noted. Last frame sent LFS. Sender maintains the following invariant LFS, that is last frame sent minus last acknowledgement received. Last frame sent minus last acknowledgement received should be lesser than the sent window size, lesser than or equal to the sent window size. Similarly, receiver will be maintaining a receiver window size, receiving window size, that is RWS, that is receiver maintains the following invariant: LAF minus LFR will be less than or equal to RWS. What is RWS? Receiver window size. LAF is largest acceptable frame, sequence number of the largest acceptable frame, and LFR is last frame received. So it is clear. Stop and wait protocol and sliding window protocol are the two flow control mechanisms in order to send the frames from the sender side towards the receiver side in a controlled manner. Thank you. May Almighty bless all of us to understand the concept of this stop and wait protocol and sliding window protocol. If any of my words had gone wrong, I am humbly asking the forgiveness of Almighty, and I am stopping my words here. ربنا تقبل منا إنك أنت السميع العليم سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك.